Today is the 15th session of this international workshop on digital image processing. Until today, we have completed various aspects related to digital image processing. Today, I am going to share my views related to unsupervised classification technique and its applications. Within this half an hour, I'm going to talk about digital image and digital image processing. Then I will focus on digital image classification. Afterwards, I purposely put this point that points needs to be considered before performing digital image classification technique. Then need for digital image classification, types of digital image classification, unsupervised classification. We will focus on concept, methods, merits and demerits. Then pre-processing required for digital image classification, applications of digital image classification, stages in digital image classification, hybrid digital image classification, then selection of appropriate digital image classification. These are the various points that I'm going to cover through this lecture. If we talk about Bloom's taxonomy, every lecture, if you are attending, it should have certain achievements. And I'm sure after the lecture, the learners will be able to remember the points needs to be considered before performing the digital image classification. If you are performing digital image classification at that time, you should keep in mind certain points, and we are going to talk about the same. Then you will be able to understand the fundamentals of unsupervised digital image classification. Then you will apply k-means clustering technique and isodata clustering technique for unsupervised digital image classification of your area of interest, related to your research topic. You can analyze remote sensing data using unsupervised digital image classification, and you can evaluate various digital image classification technique, and as last you can create your own system for digital image classification. I'm going to talk about how to develop your own indices because already Dr. Deepali Gadkari ma'am has covered the topic of indices. And on the day, one participant was asking that how we can include our own index, and for that model building is necessary. I will show how to create your own model. Not it may not be practically possible to complete all the data set, but at least I will give an insight into the topic to you through this lecture. Again, I am focusing on first lecture. What is digital image? Everything we are scanning and putting into computer, we are saying this is a digital image. But scientifically, it is not correct. When we talk about remote sensing, at that time, you should be aware that what is the difference between digital image and the image stored digitally. There is difference between the digital images and the images in the digital format. What is digital image? The digital image is a pictorial representation of phenomena with digital numbers. When you process the data, the satellite image, or you open the satellite image in any image processing software, at that time you will find that there are certain dn numbers, that is digital numbers or dn values, and that dn values are representing the spectral reflectance of the space. If you see this image belongs to Devruk, and if you see the how many pixels are there in column around, not around, fix 1150 pixels are there, and in row also the same number of pixels are there, means 1150 by 1150. This is the swath of this digital image, and if you open that digital image at that time, you may find the information of spectral signatures, or you can say spectral reflectance, or simply you can say digital numbers behind the digital image. But when you scan the image and when you open that image in any digital image processing software, at that time it is not possible to process that image. So first of all, you need to understand what is the basic difference between digital image and the image which is stored in the digital format only. What is digital image processing? Till today we have covered various aspects related to digital image processing. If you look at the title of our workshop, you will find that we have covered so many topics, and it includes image enhancement, image errors and its corrections, and other things. When you open the ADAS imaging software and under raster, you will be able to find that radiometric uh, rectifications and enhancement option is there, spatial enhancement option is there, pan streams, then spectral enhancement. These are the various options available under digital processing. Then mosaic, subset, geometric correction, reproject, check accuracy, then supervised classification, unsupervised classification. These are the various options available to you under ADAS imaging software. If we talk about digital image processing, I can simply say a systematic process to extract the information required for the decision making using spectral data, or simply you can say digital image is a process of converting spectral information into spatial information. Our today's topic is digital image classification. You will find here there are two images. One is satellite image. This is list 3 image which is downloaded from the Bhuvan portal of India, Indian Geo portal. And another one, this is the classified image using unsupervised technique. We are going to do it practically, how to classify the images using unsupervised classification. What is digital image classification? Digital image classification is a technique is a technique to convert spectral information. If you look in this image, you will find there are three bands, and these three bands may have different spectral information. After algorithm, this spectral information is converted in the form of an image, and we again need to perform or need to apply some clusters algorithms, and that algorithm may help us to classify the image, or you can say simply to extract the information from that image. What is the need for digital image classification? First of all, we need to extract the information, and for extracting the information we need to perform the digital image classification. But for that, again, we need to perform the spatial enhancement techniques, spectral enhancement techniques, radiometric corrections, atmospheric corrections, etc. And after all, when you modify the image, when you remove the errors from that image, at that time you may apply the digital image classification technique to extract the information, or Simply you can say about digital image classification is a process of converting spectral classes into information classes. If you look in the previous image, this is the spectral class A, B, B, B or C. These are the various spectral classes, and these spectral classes we need to convert into information classes. What is information hidden here? A class is representing, A means this is a spectral information, and this spectral information is representing water class. B is agriculture class. B means the spectral information, and agriculture is information class. C is spectral class, and rock is the information class. You can simply say the digital image classification is a technique to extract the information class from spectral class. When we talk about need for digital image classification, first motive is information extraction. Another one, decision making. Decision making is mostly based on information extraction. For example, suppose you are a planner, you are a district administrator. At that time, you may need to take certain information. For example, this year during rainy season in the Konkan, at various places the landslide was occurred, and at that time, from the decision making point of view, or with the view to take a proper decision, we need to analyze certain parameters like geology, then land use, and any other parameters, physiography, water holding capacity of that soil, then soil structure, etc. So on, there are certain parameters, and that parameters are required for decision making, and for that purpose digital image classification is must. Another one thing I would like to share with you, that we may extract the information through visual image interpretation, but our sensors have limitations. Our sensors may not be able to capture the information at micro level, and for that purpose digital image classification is required. Again, for research and development purposes, digital image classification is a pre-necessary step. Impact analysis, for example, it may be environmental impact analysis, it may be industry impact analysis, and so on. And for that purpose, if we perform the digital image classification, we may find out the impact analysis. For example, suppose there is an industry, and there is fire in that industry. If we apply certain algorithms at that time, to what extent that industry is affecting or going to be affected in the future, that type of decision making and that type of impact analysis is based on digital image classification. Then change detection studies. This is the important application of digital image classification. Change detection, it may be forest cover change that we are going to talk about in the upcoming part of this lecture. Then it may be land use and land cover change. It may be urban land use and land cover change. It may be rural land use land cover change, and so on. For the change detection studies, digital image classification is the pre-necessary step. Now, suppose you are going to classify your image, I mean your area of interest. At that time, you need to consider certain points before performing the digital image classification. First thing, what is the motive behind the digital image classification? Suppose I am interested to extract only water bodies, because I don't know to what extent expertise is available at the end of participants. But in the year 2015, I had applied the same technique, digital image classification technique, only with the view to digitize the rivers. For that purpose, we selected the samples from rivers only, and rest part is mentioned as unclassified, and we extracted the information automatically we can able at that time we able to calculate the area, how much area of that region is covered by the rivers. When we digitize using point line feature in any GIS software, at that time we may not be able to calculate the area covered by that feature. But when you perform or when you extract that information from image, especially using image classification technique, at that time you can calculate the area, you can find out the area covered by that feature on the earth surface. Again, you need to consider image sensors, because when you go to download the data, that data may be WIPS data, list 3 data, Landsat data, Landsat TM data, Sentinel data, so on. What are these? These are the sensors. These are the sensors. Every sensor has its typical characteristics. It provides some sensors may provide high resolution data, or some sensors may provide low resolution data, medium resolution data. As per your need, you need to consider which sensor data you are going to use, and these points you need to consider before applying any classification technique. Either you are going to classify your image using supervised image classification technique, as it is taught by or covered by Dr. B. Mahalingam yesterday, or you may use the unsupervised technique. But before that, you need to consider the image sensor. Also, you need to consider the band combination. Dr. Mahalingam yesterday very nicely demonstrated you, and for that purpose, if you interested to get more information related to various sensors, its band combination, and which band is providing which type of information, or which band is useful to extract what type of information, at that time kindly visit the website, that is gisgeography.com. gis geography gisgeography.com. This is the website that may provide you various types of essential information related to band combination and their characteristics. Also, you need to consider resolutions. It may be spatial resolution. Spatial resolution means to what extent we can identify the feature. If you are able to identify the feature which has dimension of 5 meter only, at that time spatial resolution is 5 meter. If you are able to identify the objects which has 50 centimeter dimension, at that time its spatial resolution is zero point 0.5 meter or 50 centimeter. For example, QuickBird data and some recent satellites sensors are providing very high resolution data. Again, you need to consider what is the radiometric resolution of that sensor or of that data. It means in how many bits you can get that data. Then spectral, that multispectral data, hyperspectral data, what is the spectral combination or what is the spectral resolution of that data. And again, you need to consider the temporal resolution. For example, if you are going to investigate the problem of degradation in forest or changes in forest land use, at that time temporal resolution is must. If you are selecting the data for the year 2015 for the month of January, and for the year 2020 you are selecting the month June, at that time this is the not proper temporal resolution. You need to select the data set at equal time interval, and for the same month, for the same time if possible, that may provide you the accurate information, and you may calculate the information, or you may convert that spectral information into proper information classes. These are the various points you need to consider before performing the digital image classification. Before digital image classification, certain digital image processing is required, And for that purpose, layer stacking is the first step, because you are downloading the multispectral data or hyperspectral data, and in that data each band represents the same information with different DN values, and you need to convert that single band data into digital image, and for that purpose layer stacking is the first and most important process. Then mosaicing. Why? Suppose for example, sometimes these are the various tiles of satellite images, and your study region may be covering the part like this. At that time it is necessary to mosaic these four tiles and get the satellite image for your study region, and for that purpose subset, reproject, etc. These are the various techniques that you need to apply. Again, before performing the digital image classification, you need to perform the image enhancement techniques, and it may include the spatial enhancement, radiometric enhancement, and temporal enhancement. During my demonstration, I will show you what are the various options are available in LDAS imaging, and you can do accordingly, and that will be more useful to your research. And last and most important thing is to find out the errors. It may be radiometric error, it may be atmospheric error, or it may be other errors, and it is necessary to rectify that errors and correct that errors, and it includes sensor, atmospheric, and geometric errors. These are the image processing techniques you need to apply before perform the classification. Otherwise what happens, most of the times the learners who are the beginners, they download the image various layers, I mean I can say the data, satellite data, they layer stack it and directly they perform the digital image classification using the software. For that purpose nowadays various videos are freely available on YouTube. They you watch that video and perform the digital image classification technique, but at that time they forgot that we need to perform all these processing in that image, or we need to consider all these steps before image classification of our study region. When we talk about types of digital image classification, already Dr. Mahalingam has covered yesterday that there is supervised digital image classification technique, and it is of two types. First one is pixel based, that is performed by Dr. Mahalingam yesterday, and another one is object based digital image classification. You need, when you are interested to find out the objects in that area or in your study area, at that time you need to perform the second type, that is object based supervised digital image classification technique. And when you are unaware about the objects available in that region, at that time you may use the pixel based supervised digital image classification, and you can convert the spectral class into information class. Next one is unsupervised digital classification. In supervised digital classification, what happens, the analyst, I mean the person who is performing the image classification, he is controlling the data set, he is taking the samples and spectral information, and then he assigning that this spectral class is representing water body, this X per spectral class is representing forest, and in this way he collects the various training data sets and accordingly he classifies the image. But in terms of unsupervised digital image classification, there are various algorithms, that is, or you can say clusters, that k-means clusters, iso data clusters are there, and these data clusters are used by the system for the classification of an image, and it doesn't has any control by the analyst, and this is unsupervised digital image classification. But I would like to suggest you, while performing digital image classification for your research, please focus on hybrid digital image classification. Means initially you classify the image using unsupervised digital classification technique, then recode it, or again you can use the certain training site data, and again you can classify that the same image using supervised digital classification technique, and you may extract the information, and you may convert that raster data into vector data, and you can calculate the area also. And it is necessary for the future prediction also, that time series analysis is there. If you are going to predict that this is the situation of 2020, you have taken the data for the year 2000, 2005, 2010, 15 and 20. You have calculated the area, how the forest cover is changing with the march of time, and accordingly using the time series analysis in statistics, you can predict what will be the situation by the year 2050. And this is possible only through the hybrid image classification technique. Next, stages in digital image classification. Again, layer stacking is there. I'm not going to focus detail light again on layer stacking. Second one is signature selection. But when you talk about unsupervised classification, at that time algorithm clustering is there, and these algorithm clustering are helping us to classify the spectral class into information class. So this is one of the stage of digital image classification. Then we need to classify after selecting a proper clustering or algorithm under unsupervised classification, or by selecting the signatures, by taking the signatures in supervised classification technique. Next, signature evaluation. You need to evaluate the signatures either taken by you in the form of signature selection, or the signatures collected by system itself using algorithm clustering. And these are the various stages in the classification of digital image. And at last, after signature evaluation, again you can reclassify the image. You can use that reclassified image for decision making. These are the various stages that you need to consider while processing the digital image classification. Now I will talk about unsupervised digital image classification. What is unsupervised digital image classification? Unsupervised digital image classification is performed by the system only, without considering the training sites which are given by the analyst. Or you can say system is taking the samples based on spectral values and their characteristics, and system is classifying that spectral classes into information classes automatically, and this is entirely based on the statistics of image data. When we perform the unsupervised digital image classification, it works on certain stages, and first one is algorithm clusters data. For example, under the unsupervised classification technique, you may find there are two clusters. One is k-means cluster, and second one is ISO data clusters. These are the two important clusters, and these are defined by the system only at the time of development of the software in ADAS Imagine. And computer is selecting this one of these clusters as suggested by the analyst. Then find inherent classes. This is the second step. after selecting proper algorithm, you may find inherent classes, that how many classes you want, or system may define the various classes. Accordingly, pixel based classification cluster is applied, and then spectral class map may be developed. Then you need to regroup the clusters, and when you regroup that clusters, again you may present that information in the form of thematic product. These are the various steps which we need to take into consideration while applying the unsupervised digital classification. That initially we need to select an algorithm cluster data. Either you will select k-means clusters, or you can select ISO data clusters. Then you will find inherent classes, that number of classes based on spectral information, the variation in the spectral information, their characteristics. Accordingly, system will define number of groups. Then you need to classification, that pixel based classification in clusters, that system itself is considering this group of pixels. For example, this is as depicted in the previous image. Suppose it has value 4, it has value 5, it has value 6, it has value 7. What system will do? System will define its own system. That system is going to consider the values between 0 to 10 into one group, 10 to 20 into another group. Accordingly, pixel based classification will be complete. Then spectral class map will be prepared by the system. We need to regroup, as yesterday Dr. Mahalingam said, we need to recode that spectral information, and accordingly we can generate our information class map. What are the merits of unsupervised digital image classification? First one is the extensive prior knowledge of the study area is not required. Suppose I have selected the satellite image for this region. I am unaware about the characteristics of the region, where what is the situation of physiography, what is the distribution of various parameters. And even though I can apply the image classification, or I can perform the image classification, that is unsupervised image classification. Second one, that is opportunities for human error are minimized. Suppose for example, yesterday Dr. Mahalingam was showing you that you need to select the water samples, I mean training site samples, and you are selecting the samples like this for various groups. Suppose I have selected these samples for water body, then I'm going to select these samples for settlements. Okay, and again I'm going to select the samples for roads and other built up areas, or you can say the forest area. And suppose sometimes what happens, there are fuzzy boundaries, you can say pseudo boundaries, or there are pseudo pixels, that pixels are actually representing the shadow, but we are taking as a vegetation because it is absorbing the energy received from the sun. And at that time, in supervised classification, there is a possibility that we are providing pseudo information to the computer, but in unsupervised classification it is not possible. So opportunities for human error are minimized in unsupervised digital image classification. Then unique clusters are recognized as distinct units. Suppose for example there is a deep water, that deep water will have unique clusters. It means their spectral values will be unique, and these classes will be recognized or classified as a distinct unit by the computer through unsupervised digital image. Okay, these are the demerits. I think by mistake it is written as merit. This is demerits. What are the demerits of unsupervised classification? First one, that is spectral class are not necessarily information class. Suppose, for example, there are various information classes. For example, soil is one information class, wet soil is one information class, vegetation is another information class, so on. Accordingly, your need, you may consider what are the information classes. Sometimes what happens, the spectral signatures of wet soil and vegetation may be similar. Spectral information of wet soil and vegetation may be similar, or the water body which has the planktons or other vegetations which grown into the water, their signature and the signature of vegetations will be similar. And at that time, what computer will do, he will applying the algorithms provided to the system, and accordingly he will merge water body into vegetation or vegetation into water body. Okay, so this is one of the limitation or demerit of unsupervised digital classification technique. An analyst has a little control over clusters. He can't define that how clusters are going to be merged. Only we need to provide clusters, number of clusters. How many clusters you are required? It is maximum 36, and it should be more if more than 10 at that time. If you increase the number of clusters, the accuracy of your unsupervised classification, I mean the information class accuracy, will be more. Then that spectral properties of each and every object are changing with the march of time, and it has spatio-temporal context, or you can say it has variation with the spatial and temporal context. For example, if you look at the vegetation, the spectral signatures in the month of January, then in the month of February, in the month of March, April, September, October, etc., the signatures will change with the march of time. Again, the same vegetation which is grown in the Konkan and the same vegetation which is grown in the western Maharashtra or grown in Africa, North India, may have different reflectance based on the what are the contents in that vegetation. So I can say the spectral properties of various features will have difference according to space and time, and these are not considered while providing the algorithms to the dedicated softwares. And this is also one of the demerits of unsupervised digital image classification. Most important part which we need to consider in the unsupervised digital image classification, that is clustering. There are two clustering techniques in unsupervised digital image classification, and first one is k-means clustering. What is k-means clustering? It is considering the k values as provided in the system only, and when you select these clusters, automatically the various spectral classes are divided into information classes. I have written here one note, that is k-means algorithm assigns each pixel to a group based on an initial selection of mean values. It is considering the mean values. Suppose for example it is already presented by Dr. Amrita Agarwal ma'am. What computer is doing, it is collecting the information. Suppose this is the site, it is calculating the mean values for all these surrounding pixels, and accordingly that spectral class is assigned a different information class or grouped in a information class. This is the k-means clustering. What are the merits of k-mean clustering? It is only one merit is there: simplicity and speed to run the iterations. This is the merit of k-means clustering. What are the demerits? It does not yield the same result with each run. Suppose you are using the same data set, I mean the same satellite image, and you are reproducing or you are classifying that image using unsupervised digital image classification. What happens? You may test the same, that each time or during the each run there may be a little variation in the spectral classes, I mean the spectral groups, that is which are defined or designed by the software. Why it is happening? Because it depends on the initial random assignments. Another demerit, it is sensitive to outliers, and one must needs to specify the number of clusters. It is your duty that you need to define the clusters. How many clusters you are in, how many clusters you are interested. Suppose you are interested into 15 clusters, you need to define their 15s. If you are interested in 20 clusters, you are interested to define their 20. But try to provide their value, maximum value, because it will help you to classify that image very properly. Okay, another technique, that is iso data clustering. What is iso data clustering? It is a iterative, self organized data analysis techniques. What does mean by iso data? Iterative, self organizing data analysis technique, clustering. And this is also available in any image processing software. And when you compare with k-means clustering, the results which are developed through iso data clustering are more accurate, but it is time consuming, and it is depends upon to what is the extent of the area of your research. When we talk about the merits of iso data clustering, it is good at finding the clusters, true clusters within the data. Within, if you are interested to find the true clusters within the data, it is really helpful. Then it is not biased to the top pixels in the image. Then top pixels means, because there are we have already seen, this is the band 1, band 2 and band 3. Suppose top pixel is band 3, then band 2, then band 1. Sometimes what happens, the image classification may be affected by the top pixels, but in case of iso data clustering, it is not affected by such top pixel values. Again, it does not require image data to be normally distributed. That image data is abnormal, even it is distributed with very much ups and downs in the reflectance. That type of data can be also classified using this technique. Then it does not require image data, sorry, it is already covered. Then clusters signature can be saved, which can be easily incorporated and manipulated along with supervised spectral signatures. This is the important thing. Why? Because I already talked about hybrid classification. And in ISO data, you can save these clusters, and these clusters may be used as a signature in the supervised classification also. And these are the various merits of using the ISO data clustering technique in unsupervised digital image classification techniques. What are the demerits? Demerits of ISO data clustering are it is time consuming. I already talked about this, that it is taking lots of time. And another one is it requires the maximum number of clusters, conversion thresholds, and the maximum number of iterations as impact to an algorithm. These are the two demerits of ISO data clustering are there. Another one, selection of an appropriate digital image classification technique. Which one is better? Either supervised or unsupervised or hybrid. It depends on your motive and what are the parameters of your data. Suppose if you have very high resolution data, you can easily identify each and every object. At that time, supervised classification technique is useful. If you are able to identify the objects at that time, object-based supervised classification is most useful. If you are unable to identify the object, each and every object, at that time, pixel-based supervised classification technique is useful. Then, if you are unaware about all the spectral information or spectral classes, at that time unsupervised classification technique is useful, and sometimes you may collaborate or you may use both the techniques, that is supervised as well as unsupervised, that is hybrid. It means selection of an appropriate digital image classification technique is based on which data you are going to use, what is the quality of that data, how atmospherically, radiometrically, and geometrically correct is that data, and which software you are going to use, and what is your motive. Based on you can select your own classification technique. Suppose this is the image, and I am interested to find out only road network. For example, in case of India, there are national highways, or you can say express highways. We can extract the information of express highways using the supervised classification technique, because the material which is used to construct that road is more or less similar. Hence, the reflectance or the spectral values of the each and every road more or less similar, and at that time supervised classification technique will be helpful in your research. There are various applications of digital image classification. One is land use and land cover change analysis, land use and land cover change detection. Another one is forest cover change, then change detection studies, environmental analysis, water quality, hazard and disaster analysis, urban growth analysis, distribution of settlements, etc. So on. There are n number of applications are there of digital image classification. Now I will focus on example of forest cover change. I hope that this may be helpful to you. This is the work carried out in the year 2015. At that time, ADAS Imagine 9.1 was used and hybrid classification technique was applied, and the data set was taken for the period of 1989, 99 and 2009. Okay. Then classified images were uh, converted to polygons, desolid, and overlay analysis techniques were applied, and later on that data sets were exported to Excel with the view to, you may find here that these images are representing the classified images for the year 1989, 1999 and 2009. You are interested in these results, but beyond that you are more interested in this table, because with the help of this table you can prove that how the forest cover is changing with the march of time. At the time of classification of image, we had selected only four parameters, that is dense forest, then moderate forest, scrubs, vegetations, then non-forest area. And under non-forest area we considered agricultural land, settlements, etc. Okay. And we had calculated area, and also we had calculated how the area is changing from one type to another type. The same results were displayed with the help of graph, graphs, and with the help of positive negative changes. Either the forest cover is changed negatively or positively, and that you can find here or you can observe with the help of this graph. This is the pattern of forest cover change, that dense forest to dense forest, how much area is converted during the 89-99. I may not say converted, it remained as dense forest to dense forest, and it was 62%. And you will find that dense forests were converted to scrubs, sparse vegetation, etc., to agricultural land, and non-forest area, etc. Again, moderate to dense, moderate to moderate, moderate to scrub, and moderate to non-forest. Again, scrub to dense. This type of how it is changing, and for that purpose we had applied a technique from ArcGIS. And this is the graph, and again these are the change detection graphs. Again you will find that during the period of 1991 to 2009, what was the change in the forest cover in the study region. And finally this table was prepared using the information and periodical change in percentage during the first decade and during the second decade. You will find that during first decade approximately 83.97% plus was there in terms of percentage, and the after performing the digital image classification, we verified the data sets either through field visit or through the historical images in the Google Earth. And this was the one of the product of our research work after applying the hybrid image classification technique. Okay. See, during the last 1 hour, we have discussed about digital image and digital image processing. What is the need for the digital image classification? Then points to be considered before performing the digital image classification. Then processing required before performing digital image classification. Then types of digital image classification, stages in digital image classification, applications of digital image classification, and selection of an appropriate digital image classification techniques. These are the various parameters, various aspects that we have discussed during the last 1 hour. Okay. If you have any queries, kindly feel free to ask. Otherwise, we will move towards the demonstration if you are interested for the same.
Signature is completely the components are not showing in QGIS. So
No, you may not be able to use the signatures of ELDAS into or signatures of QGIS into ArcGIS. This is not possible. Only what you can do, you can open that classified image, I mean the final thematic product, into different software, and accordingly you can use the merits and demerits, I mean the positive aspects available in that image. For example, that I have demonstrated regarding forest cover change. We initially at that time it was not possible into ELDAS itself to convert raster to vector. So we took that raster layers into ELDAS, sorry, ArcGIS, and in ArcGIS there is one option, polygon generation. In this way we converted raster into vector. Again we dissolved as it is demonstrated by Dr. B. Mahalingam yesterday, and later on overlay analysis using intersect method is applied, and applying this method we calculated the table into GIS only, that how the area is changing from one type of forest to another.
yes, sir. Actually, I had planned to quickly analysis the image
Okay.
because there is in QGIS to collect the signature. It is very tedious process. In one signature, it is time to process at least 45 seconds like this. So to collect 100 signature sample for one class, so for 5 class it is 500. It is very laborious work. So I had planned to collect the signature from Erades and bring it in QGIS and apply all the machine learning technique. But actually my project failed due to this lots of barriers.
Even I can suggest that you can use the ArcGIS Pro for 2 months. Okay. Now
Yes.
there is a project, I can say a certificate course on cartography, and it is provided by ISRI free of cost. And for that project, for the month of no, for 2 months, because that certificate course will start in the month of February and it will end in the month of April. So for 2 months you will get a license of ArcGIS Pro to work or to complete that certificate course, and during this span of time you can complete your task also.
Okay, sir. Thank you.
Yeah, thank you. There is one question in chat box, that is in unsupervised classification. ISO data is better one because it is considering the various aspects. In K means it is considering the nearest neighbor, it is calculating using the principle of nearest neighbor analysis. But you can say that both the clustering techniques are useful, and these accuracies are slightly vary. from ISO data to k-means, and for ISO data you need more time for the running of iterations. Hasib, okay sir, for ISO data how to enter the class from to? Okay, it depends upon the spectral information which you have and the spectral variation. For that purpose you need to look into metadata and the properties of various spectrums, not spectrals, various spectrums, that uh, what is the variation there. For example, if you talk about water bodies, and if you look into the spectral information or spectral attributes, at that time you may find that what is the variation. If there is much more variation, you can give the higher values, and if there is not much more variation, you can assign the lower values. That is from to how many classes you are interested. From means minimum. For example, suppose I am assigning the value 10 to 20, that minimum 10 groups will be classified by the system, and 20 means maximum 20 groups will be there. Thank you all. Today I'm one of the organizers as well as speakers. Thank you very much to you all.